All right, number 50. So just drawing the thing here, um, going through and I just start labeling everything, right? So they want to know X on the bottom, and so I can just start labeling everything, right? Because I know information about all this stuff. I know that that's 60 because 30, 60, 90, right? We can add all three of these up here, all, those two, and then of course we know that has to be 60, so this has to be 30. And then I just turn the whole thing sideways, right? And then, wow, look at that. It looks a lot like number 47. Instead of 100, you have 5. But other than that, everything pretty much is the same. Except you're trying to find a different side, right? So, um, X over here, remember that corresponds to right here. So now you're trying to find this side instead of before you were trying to find, this blue side down here. So just remember you're looking for this pink side here now. This is X, okay? All right, so number 55. Um, so basically this bottom line is the mist, uh, our mist laser beam. Um, and we know that that top line is where it's supposed to be. And they told us that that angle is 0.5, right? So we go ahead and we set this up. They told us that the distance from ourselves to the moon, and remember that top one is the distance to the actual moon, and the bottom one is the our missed laser. Um, so basically, going through and just labeling everything there. Um, I'm finding out what all of these angles are because they told us that that one's 0.5, and then I know that the other is a right angle here. So can tell that this, obviously, this angle has to be 89.5, right? Just using that everything has to add up to 180 rule. So now we can set up that proportion, that law of sines that we've been doing, right? 240,000 corresponds to this angle here, 90, right? And then we're trying to find x, and that corresponds to this. So we actually didn't even need this guy up here. So basically, if b is, or if x is less than 1,000, that'll give you your answer right there, if we've missed the moon or not, because the moon is, that far. That's the radius. Okay. So number 56, pretty straightforward as well. We have a lighthouse, which I drew in blue. We have the ship down there, and then we have this angle from the top of the lighthouse, right? They said it was 53 or 23 degrees. So we're just setting this up. They said the lighthouse is 200 feet tall. So we're setting up that proportion because they want to know how far it is from the top of the lighthouse to the ship, right? Oh, and I'm sorry. I think they're saying actually how far is the ship from the base of the lighthouse. So now that I've drawn all of this, just go back through and you have to actually solve for this side right here. Let's see, I'll draw it in red. This side right here. I apologize. They said from the base, right? So this is our x. This is what we want to solve for. So we have to set this up just a little bit differently. Um, Not too bad, but let's see. If that bottom part is our x, then it would just be sine 23 down here. That's how things would change. Okay. All right. So yeah, just set that up, solve for x, and you'll be good to go. Cool. All right, moving on. We're on number 61. I'm just redrawing this diagram here, and it says, how tall is the tower, right? So we know that that distance is 325. It tells us on the bottom there that the distance from the building to the tower is 325. And then it tells us both of those angles, 25 and 39. And they want to know how tall is the tower, right? So they want to know those two distances basically added together. So again, really simple. We just find what those missing angles are by needing to add everything up to 180. So that's 90 degrees. This is 25, so this has to be 65, right? That's where we got those numbers from. And then from there, we just set up our little proportion, right? We have two different ones. We need to solve for x1 and x2. So we set up those two different ones, and then we can add x1 and x2 together, and we'll be good to go. So 325 corresponds here to the angle 51, and that's why we have this. And then 325 here corresponds to the angle 65, and that's why we have this. And then obviously x1 and x2 correspond to, x2 corresponds to 25 and x1 corresponds to 39, right? So solve and then add those two together, and then you'll have this full distance here. Okay. So 63, there's just wasn't enough info exactly. I needed to see number 62. So anyway, moving on to number 65 here. We estimate the height of a mountain. Okay, so we just are labeling everything, labeling all of our angles. We need to figure out, what everything is so that we can set up, a proportion, right? So 1,000 corresponds to the angle 55, and so we set up 1,000, or we're using the law of sines, right? Setting that up, and so forth. So solve for x, and you'll be good to go. For these, I know that I'm telling you late in the video. I just assume that you know how to do this, but you can plug into your calculator and figure out what the sine of 55 is, and then we cross multiply, and then we'll have to divide and solve for x, right? So we're just setting these. I'm setting these up for you because it's really simple for you to just go through and solve. Okay. All right. So the last problem here for number 62, or for 6.2, is number 67. So I set up the problem here, and we have the sun on the left hand side, and we know that this angle is a right angle right here. And then they told us that this angle is 89.85. And then they also told us that the distance from the Earth to the moon is 240,000. So that's why I've labeled that there. And then they tell us, what else do they tell us? That's about it. So I go ahead and solve and figure out what this angle is here. And then I set everything up, right? They want to know the distance from the Earth to the sun. And so we set everything up. Yep, so we just need to solve for x, right? And so x is across from this 90-degree angle, so x over sine of 90. And then we can set this side up too. Okay, awesome. So that should finish up 6.2.